In this video, we are going to be covering the practice problems at the end of the PDF for Unit 1, Notes 4. And these 8 practice problems are not too difficult, just reviewing our sig figs and the types of graphs and organizing data. So let's go ahead and get started with number 1. Number 1 says round the following numbers to 2 significant figures. Okay, so what we want to do is, again, just take a look at these numbers and round to only 2 sig figs. And the way we do this is we always start from left to right. Okay, so if we want to round 13,589 to 2 sig figs, well, I'm going to start from left and I'm going to put the number 1. Let me go ahead and decrease the size of my font here. I'm going to put the number 1 for the 10,000th place. For the 1,000th place, I'm going to then round here. So I have a 3 here initially, and if I put a 3 in right there, the next 3 numbers would have to be all zeros that are insignificant. They're not significant numbers. But that's not correct rounding. Even though this only has 2 sig figs, we didn't round it correctly. And the reason for that is because of this 5 right there. The 5 in the middle rounds that 3 up. So if we round 13,589 to 2 sig figs, the correct answer would be 14,000. Okay, so for this one, 889, start from left to right, writing down our sig figs. 8 is the first one. That's a non-zero number, so that's significant. And then the next one is going to be a non-zero number as well, so it is significant. The middle 8 would round up to 9 because this 9 at the end rounds it up to a 9, 0. So let me go ahead and type that in here. 890. Okay. I could just get rid of that one. This next one, 0.000024, so on and so forth. I'm not going to read out the whole number. Start from left to right until you get to significant numbers. That first 0, not significant, so we can go ahead and jot it down. The next 3 zeros, they are in the decimal place, but remember, they are not trailing in the decimal place. So that's the only case where these zeros would be significant in the decimal, as if they're trailing. So we can go ahead and jot those down. They're not significant. They don't count. That first 2, though, that is significant, so that's our first sig fig. And then the next number 4 would be significant. We just got to make sure, does the 1 after it round it up? In this case, it does not, so we're going to leave it like this, 0.00024. And that way we have 2 sig figs. And finally, our last one, 0.725. The first 0, not significant. 0.7, so that's our first sig fig. And then our second sig fig is going to be 2, but we got to make sure that the number after it doesn't round it up, and in this case it does. 5 does round it up. Okay, so there's number 1. Those are all of the numbers rounded to 2 sig figs. Number 2 says, write the answers to the following calculations. Be sure to use the correct number of significant figures. Okay, so these are just simple multiplication problems. I am going to type this into a calculator. And for number 1, I get 133.0875. That's what my calculator tells me. Okay, let me go ahead and put in the unit as well. Meters squared. Okay, this, however, is not correct because it's not the correct number of sig figs. If I want to round this to the correct number of sig figs, I got to review my multiplication rules. And remember, for multiplication and division, you take a look at the entire number and count the number of sig figs. So how many sig figs are there in 15.75? Well, it looks like there's 4, so I'm going to put the number 4 here. Let me go ahead and select a different color to notate that this is not the answer. And how many sig figs are there in 8.45? Well, there's 3. Okay? So I got to go with the lowest amount. So the lowest amount here is 3 sig figs. Therefore, my answer can only have 3 sig figs. So if I go ahead and round that back out to 3 sig figs, I get 133 meters squared. Okay, so that would be the correct answer that you would give me if we had this sort of problem. The second part, 5,650 divided by 27. If I do that into a calculator, I get a big number. That's 209.259259 repeating, so on and so forth. So 259 repeats pretty much forever. But that is incorrect. So let me actually put in the unit. Can't forget that. This is going to be liters per minute. Okay, liters divided by minutes. But how many sig figs are there in each of these numbers? So 5,650. That first 5, the 6, and the second 5 are significant, but this last 0 is not. So we have 3 sig figs here. And 27 has 2 sig figs. Okay, so what's my lowest amount? 2. Therefore, my answer can only have 2 sig figs. So if I'm going to go ahead and round this out, I get 210 liters per minute. So these are the correct answers for number 2, 133 and 210. Number 3 says the composition of the mixture of gases that make up our air is best represented on what kind of graph? Well, if we're taking a look at a composition and representing them as parts of a whole, the best way to do that is with a circle graph or a pie chart. So answer A should be the correct choice there. Number 4 says density equals mass divided by volume. If a chemist is calculating the density of a substance with a known mass of 23.523 grams and a known volume of 17.5 liters, how many significant figures will the result have? What should the value of the substance density? Okay, so a couple of things that we're doing here. They're doing a density equation. So if we recall from a few notes ago, the equation for density is D is equal to mass divided by volume. So density equals mass divided by volume. So what type of calculation do you have to do here? You have to do a division. Okay, so if we just plug in these values, density is equal to the mass of 23.523 grams divided by, let me go ahead and fix this, I typed this in wrong, 17.5 liters. Okay, how many sig figs are there in 23.523? Well, there's 5 sig figs there. And how many sig figs are there in 17.5? 3 sig figs there. Okay, so our answer has to be 3 sig figs. That's the answer to the first part. The first part is that we need 3 sig figs. Okay, and if I go ahead and do this in a calculator, 23.523 divided by 17.5, I get an answer that is 1.34417,143, so on and so forth. But if I want to round this to 3 sig figs, I'm going to just erase them until I get to 1.34, but making sure that the last number doesn't round this 4 up. In this case, it does not. So 1.34 grams per liter is my final answer. Number 5 says, a demographics researcher needs a graph comparing the population of the 10 largest cities in the world. What would be the best type of graph to use? Well, if you're comparing 2 different things, you're going to be using a line graph. You're showing a relationship. Okay? So a line graph, because it shows a relationship. Number 6 says, a student measures the length, width, and height of a fish tank. She finds that the fish tank is 105 centimeters long, 75 centimeters wide, and 80.5 centimeters high. What is the volume of the fish tank? Show the correct number of significant figures in your answer. Okay? So the calculation part is actually really easy. We've got length times width times height. We've got 105 centimeters, 75 centimeters, and 80.5 centimeters. So if you want to find the volume of this, a volume of a fish tank is going to be easy. It's just length times width times height. Okay, so the volume in this case is going to be 105 centimeters times 75 centimeters times 80.5 centimeters. So I'm going to go ahead and do that on my calculator really quick and get an answer for you. So when I did this in a calculator, I got 633,937.5 cubic centimeters. But because we're not measuring with a super precise tool, let's say we're just using like a standard school ruler, there's no way we can have that level of precision. So we need to actually round this down to the least significant amount of digits. So in 105, there's 3 sig figs there. 75 has 2, and 80.5 has 3. So my lowest amount is 2. So I have 2 sig figs right there in 75. Therefore, my answer can only have 2 sig figs. So I have to round that 633,000 down to V equals 630,000 cubic centimeters. All right. So that's practice problem number 6. Number 7 says complete the table below. So what we're going to be doing is just reading each one of these off and then describing what's the best type of graph to use in that scenario. The first one says changes in the mass of a rock over time. Well, that sounds like a relationship, and it'll be covered in the notes that if you have something that's comparing something over time, you're going to be using a line graph, and that's the best type of graph to show a relationship. The second one is the fractions of different gases in our atmosphere. Well, if you're showing parts of a whole, that sounds like a pie chart, also known as a circle graph. The maximum speed of several different cars. Well, it sounds like you're doing a comparison here, and when you're doing a comparison, the best type of graph is a bar graph. Okay. The next one says how the height of a rocket changes with time. Again, any single time you see time as one of the variables, that's going to be a line graph. And then finally, last one, the relative amounts of different minerals in a rock. To me, that sounds like parts of a whole. You're comparing all the different parts. So that is, again, a pie chart / circle graph. Number 8 says the extent to which a measurement approaches the true value is referred to as. Well, to me, that sounds like accuracy or precision. In this case, the correct answer is accuracy. Although a measurement of 6.1345790 centimeters is very blank, it may not be accurate. Okay, so the answer to that is precision or precise. Okay, it's a very precise answer, but it might not be accurate. Copper has a density of 8.96 grams per milliliter. Students have been trying to measure the density of copper, measuring the mass and volume of different copper objects. These are their results. So they've got 3 different densities here, object 1, object 2, object 3. What can you say about the accuracy and the precision of their results? So if they're comparing these values to 8.96, I would say that these values are pretty close to one another. 8.79 is pretty close to 8.75, and it's also pretty close to 8.82. There's a little bit of a difference between 8.75 and 8.72, but they are all pretty far away from 8.96 in terms of measuring for density. So, although their answers are precise, they are not very accurate. That's the answer that I would give here. Just because there's too much variance here in the decimals, they could be getting much better values in terms of finding densities. And later on, actually, you'll be able to do a lab on your own with your group, calculating the densities of different materials, and you will need to be able to find the densities to either the first or the second decimal point. So there is some level of accuracy there. Well, there you have it. Those are the practice problems for Unit 1, Notes 4.